we call it as clinical data or clinical study data. So relevant data we kept in one table, and each table we call it as a domain, and these domains are called as domains and data sets. So we kept all the vital signs data into one table, we kept all the laboratory test reports into one table, all the demographic data into one table, and whatever the data that we have collected in the clinical data. And the 100% data we segregated, and we kept the relevant data into one domain, and we submitted the data as Ethereum data sets or Ethereum domains. Now, tell me one important thing. You want to prove that your drug is safe. If it is a phase 1 study, that is the primary objective of your study. And if it is a secondary phase 2, you want to prove that your drug is very effective, and along with as well as you are going to prove that your drug is safe. So, how we can prove that your drug is safe, and how we can prove that your drug is very effective? And if it is effective, out of 1,000 subjects, how many subjects are recovered from that? How many subjects didn't recover? How many subjects are recovered via medium? So, what is the percentage of success? But every time, whatever the drug that we have, it may not cure all the 100 subjects, out of 100 out of 100, but how many subjects have been cured, and how it is working, what is the level of efficacy, what is the level of safety. Do you think that the drug is whether it's working or not? No. We are going to have sometimes it may work partially, 25% or 50% or 75%. And how we can prove that one? If you want to prove that one, you should do the data analysis. Whatever the clinical study data that we have got. So far, we kept all the data in Ethereum domain. Now ultimately what we do, we have to do the data analysis. Okay? We have to do the data analysis. And with analysis, we are going to get an analysis report. Based on the report, we can prove that yes, my drug is working. But how we can prove that one? How to do the analysis? Now, if you want to do the data analysis, so far, what we have done, we have created Ethereum datasets. Now, whatever the Ethereum datasets that we have, somehow these datasets are not fit for analysis purpose. We cannot do analysis by using Ethereum datasets as a source dataset. We created Ethereum datasets for the sole purpose of submitting this data. Okay, submitting this data. Can't you hear my voice, guys?
You can hear, sir.
Am I audible, right?
Yes, sir.
I think you should better log out and log in back again. Okay. So we put all the data in Ethereum datasets, and what is the purpose of Ethereum? Whatever the clinical trial data that we have got, submit the data in a standardized format in CDSCO or Ethereum IC guidelines. So by using CDSCO guidelines, we have to submit Ethereum data to that FE or regulator that. So you are going to submit all the data, and that is an Ethereum submission. But this data, whatever the data that we have, these datasets are not fit for analysis purpose. We cannot use it for analysis purpose. Then how to do the analysis? Ultimately, we have to do the data analysis. Since these Ethereum datasets are not fit for analysis, we should create an intermediate dataset to do data analysis. And that intermediate dataset should be useful, and we should use that intermediate dataset for analysis purpose. So that's why those datasets are called analysis ready datasets. That means those datasets are 100% for the purpose of analysis. To do analysis, we are going to create some intermediate datasets. Those datasets must be analysis ready. Now, how to create this analysis ready dataset? And by the way, what kind of analysis that we are going to do? We are going to do different kinds of statistical analysis. Sometimes we do only demographic data analysis, descriptive statistics. Sometimes we are going to do, ANOVA, ANCOVA, analysis covariate, Fisher test, t-test to probabilities. And we are going to use different kinds of statistical procedures. Now, whatever the analysis criteria that we are going to create, now this data set must be ideal, and you should figure that one data set should support all different types of statistical analysis. Now, whatever the data set that we are creating, and that is analysis ready. How to create the data set? What is the data set that we are creating? Whatever the analysis data set that we are creating, and now that data set is called as an ADAM data set. Okay. Now, to create an ADAM analysis ready data set, proceed is to propose some models, and those models are called ADAM. What is the full form of ADAM now? ADAM means analysis data model. So, to create analysis data sets, they have proposed certain models. Those are called analysis data model. So, in this analysis data model, they have proposed certain blueprints. How we have Ethereum in the same way, we have ADAM. Now, how to create this ADAM data set? To create this ADAM data set, from Ethereum data sets, we need to follow certain guidelines. And what are the guidelines that we have? And those guidelines are called ADAM IC guidelines. What is ADAM IC guidelines? Analysis data model implementation guidelines. So, whatever analysis data sets model that they have, to create this data set, in this model, we have some guidelines. Those are called ADAM IC guidelines. Remember, in the past, when we have a clinical trial data, I told you we have to submit all the data in certain tables. Now, series proposed those tables, and I told you those tables are called Ethereum tables. What is Ethereum? Ethereum means analysis data. Ethereum means study data. And the data model. How to create this Ethereum data set? To create this Ethereum data set, now they propose again some guidelines. What are the guidelines they have proposed? Ethereum IC guidelines. Study data, tabulation model, implementation guidelines. In the same way, now they have proposed a few models for analysis data sets. Those models you can find in ADAM document. And to create the ADAM data set, they propose second guidelines. And now those guidelines are called ADAM IC guidelines. What is the question right now we are using? If you have started in using of these guidelines 2 years back, we used to use 1.2 guidelines. But now we have latest version, which is 1.3, ADAM IC 1.3. Remember what was the guideline that we have seen in ADAM IC? 3.2. Right, we have 3.3 is also available and 3.4 is also available. And I'm going to take one class on what are the updates that we have in 3.3 and 3.4 later. And what is Ethereum version that we have? To create this Ethereum data set, we have a Ethereum model, study data tabulation model, and in that we use version 2.0. That's the version that we are using. So to create this Ethereum IC version that we are using 3.0. In the same way, we have ADAM. ADAM also we are using 1.0, and to create that ADAM IC, we have ADAM IC guidelines. These are 2.0, and the guidelines that we are using ADAM IC 1.2 and 1.3. Now, from today onwards, we are going to discuss what are the guidelines that we have. Based on the guidelines, how we can convert Ethereum data sets into ADAM data sets. And what is the fundamental rule of analysis data sets? Analysis must be how? It must be analysis ready. What do you mean by analysis ready? What does it mean? So analysis ready means if you have a data set, whatever the data that you have, you should use this data set. This data set must be useful by any statistical procedure. Ultimately, you should get a statistical report. By generating a statistical report, you no need to transform this data set. That means whatever the data that we have, it must be ready-made. Whatever the data we should use directly for analysis purpose. We should not transform, we should not transpose. Directly, data must get involved in analysis purpose and you should get analysis. So that's why whatever the analysis ready data set that we have, we can say this analysis ready data set must be one clock a day. What do you mean one clock a day? There must be in between the analysis data set and analysis report, there must be only one procedure we should use and you should get analysis report. So that means whatever the analysis data set that I have, by using this data set, for example, if you want to have descriptive statistics, I don't need to change anything in this data set. Simply by getting a proper means or a proper frequency, I should get the report. By using ANOVA, ENCOVA, and t-test or a several analysis, I should get the report directly. Sure, you should not transform or you should not transpose. But what we can do, if you want, you can write a select statements like a statement or if statement, or you can merge it. That is the only thing that we can do. We cannot do anything other than that. If you have any data set like that one, that is called an analysis ready data set, and we call it as simply one clock a day. And what is that one procedure? It is a statistical procedure. By using the statistical procedure directly, you should be able to get the report. Understand this one a little bit? Now, and by the way, by writing an ADAM, you should always write a small a in the third position. Analysis, data, model, implementation, characters. Now I'm going to tell you, in today's class I'm going to explain what is ADAM in a nutshell. By saying that you should be able to understand what we are going to do next 15 to 20 days. Then I'm going to take a vital signs data set. Okay? And in the vital signs, remember in these data set, what are the important variables that we have? We have study ID, we have a domain, we have use object ID, UES, UPJ ID, and then remember we have sequence, query, reference ID, response ID, and then we have the BS test CD. I'm getting a BS, and test CD is not important to this because I'm getting BS test. And then remember we have category and subcategory. We have BS OR RES, then we have the BS OR RESU, then we have the BS STRESC, then we have ST RESN. Then we have one more variable called BS ST RESU. And then we have the status, reason not done, we have other variables, location, position, we have so many other variables. And along with that, we have one more variable called visit. And then we have the BS DTC. Remember, if you take multiple times in one visit, remember what are the 5 protocol plan timing variables that we have? TPT, RF, RFDTC. And then we have one more important variable, BS BLFN. What is BLFN? So in today's class, I'm looking at only important variables from Ethereum. What is the data set, by the way? Ethereum. Vital signs specific domain. Is the data set. So I'm taking only one thing. Use subject query, say for example 101. BS test is, say for example, systolic blood pressure. Is the test. And then we have STRESN and STRESN value, I got say for example 140. And it is a HG. It is say for example, a treatment. And DTC is 10th of January 2023. But I'm writing DDMMYY 10 dot. But you should know that, right? How we should write it? This is actually ASO format 2023 -01 -01 -10. And then PLFL we have a missing value. I'm taking the same 101 subject. Again, I'm taking the same systolic blood pressure. I'm taking only one test. And then the value is 145. And again, it is MMHG. And then this is also retreatment. And this is 2023, okay, -01 7. So in this way, I have corrected systolic blood pressure only, and I'm taking only systolic blood pressure like this one. Next. I started the treatment on 13th of January. This is what we have seen. Suddenly, which observation is going to have BS PLFL is equal to by? Any idea?
30.
Okay. This observation is going to be BS PLFL equal to?
30 by.
For this observation, I'm writing it because I started the treatment on 13th of January. You know the definition of PLFL, right? What's the definition for PLFL?
The The most non-recent missing value on or before treatment
The
getting
most
started.
recent non-missing value on or before treatment getting started. The treatment getting started is on 13th of January. So this is also 13th January. Now, whatever the value that we have, this is called DLFL value. So for other observation, VS DLFL is equal to y. So this is what we have seen in FD. Now I want to use this for analysis purpose. Now it is unfit for analysis purpose. Now what I'm going to do from this data set, I'm going to create an random data set. Now how to create an random data set? I'll show you that. Now this is how I'm going to create a random data set. The random data set now, I'm going to have a use of big query. Now, VS is test. What is the test that we have by the way now? Systolic blood pressure. And systolic, what is the STRSU that we have? MMHC. Now what I'm going to do, I'm going to concatenate this MMHC value. Now I'm going to create a new parameter now. You know what the new parameter I'm creating, how I'm creating? This is how I'm going to do. Now, systolic blood pressure. Typically, if you want to get this value, which two variables you need to concatenate?
VS test and VS STRESU.
VS test and VS test. So now I'm going to concatenate VS test with the VS STRSU. I'm going to keep an STRSU within the parenthesis. Now I'm going to create a value like this one. Now this is called as a parameter. What do you call it? We call it as a parameter. Now tell me, parameter is a concatenated product of which two variable values?
VS test and VS
And
STRESU.
STRSU. Okay. Now, as soon as I created a parameter, now this is the question that I will get. So when you create a parameter, we are going to get a meaningful question. What is the systolic blood pressure in MMHG? Now tell me what is systolic blood pressure in MMHG in the first visit? 140. Now, in whichever variable that we have 140, now that variable, we are going to change it as a value called a variable called eval. Eval means analysis value. So now tell me, is 140 present in which STRM variable?
STRSU.
STRS. So we convert the STRS into a variable called eval.
Eval.
Okay, now this is how we are going now. So I'm going to write everything like this one now. So in the first observation we have 140, in the next observation that we have, what is the next that we have? 145, then we have a 143, and then we have a 148 that we have, and then we have a 147 that we have, then we have a 141 that we have, then we have a 139, and then we have 133 that we have, then we have 131, then we have 130, then we have a 129, One 122, 126, we have 127, and we have 120, 130. Okay, now this is something. Now tell me, which level you should have a PLFL, VS PLFL? Which observation is called VS PLFL is equal to y? Then we have 140, right? In whichever record we have PLFL is equal to y. In that record, what is the eval value that we have? Now that value we are going to keep in a variable called base. Tell me in which record DLFL is equal to y? This record. When we have DLFL is equal to y, what is the value that we have?
148.
148. Now we are going to have 148. We are going to populate 145 like this. I think you do. In which way we are going to populate that one? What is the variable name?
Base.
Base. So tell me, what is the definition for base? How we can explain out the base? How we got the base value? How we derive the base value?
The value I got to VS DLFL is equal to y.
Record, the DLFL is equal to y. In that record, whatever the eval value that we have, that will become base value.
Base.
Now we are going to create a new variable called change. Now what is the change? The formula for change is eval minus base. So what is eval minus base? When we have a 148 minus 148, the change is
0.
So what is the change? 147 minus 148, the change is minus 1. What is the change? 141 minus 148, the change is minus 7. And what is the change here? 139 minus 148, it is going to be minus 9, isn't it? And then the change is going to be 133 minus 148, and the change is going to be minus 11, isn't it? Is it true? No. 133 minus 148. 7 plus 8, 15, right? The change is minus 15. And what the change here? The change is minus 17. And what the change here? It is going to change is minus 18. And what the change that we have here? And the minus 19. Again, what the change that we have here? Minus 18. So what the change that we have here? Minus 21. And what the change that we have here? Minus 22. And what the change that we have here?
Minus 26.
26. 26. What the change that we have here? Minus 27. This is the change. If you have a change like this one, now what is the percentage in each HG? Okay. 148 here minus 1 change, okay? 100 can the change only. Now we are going to calculate the percentage change, and by the way, we are going to have a formula for the percentage change, which is nothing but again change divided by base into 100. This is the formula. This is the formula for change. Okay. Not worry about this one. This is the formula. So based on that, we are going to create a percentage change. And the change into 100 can change. Now this is the calculation that we are going to do. And now on a whole, this is how an Adam data set looks like. If you understand this concept, now you will be able to understand the whole Adams. Understand everybody? Sorry. Okay. This is how we are going to. Okay, this is our STM data set. Now this is how we are going to create. I'm going to ask you a few questions. Tell me how we created the parameter.
Concatenating the VSDST and VSDST.
How we created the value?
STRESU.
And what is the base? Base is nothing but
The value
in whichever record,
DLFL
DLFL is equal to y. Now in that record, whatever the value that we have, that has become a base value. Now what is the formula for change? eval minus base.
Eval minus base.
So now by taking the change in which digit, what is the change? Of course, we have taken the digit value also. So for example, by the end of the 50th digit, what is the change? The change is minus 27. By the 10th digit, what was the change? By the 10th digit, this is the change minus 90. If you want to do analysis like this one, you cannot do the analysis directly. Now we have to create intermediate data set. Now that data set is called the name Adam data set. This is the Adam data set. And how to create this Adam data set? How to create this Adam data set? We have few guidelines, and that guidelines we have named Adam IC. Understand? Now this is the data set. I can use this data set directly for analysis purpose. Okay. Now I want to know that by the end of the study, what is the change? If you want to know by the end of the study, what is the change? Which observation you need to calculate? You need to take into consideration to if you want to find the final change. Which observation you need to take?
Base.
Which observation you need to take? Observation. Because now which observation that we are going to take for analysis purpose? We are going to create a variable called analysis flag ANL01FL. So that analysis flag we are going to have y for this observation because I'm going to take this observation for the final analysis. So that if I take this observation, I will come to know what is the final difference, final change in this study for systolic blood pressure for this object. Because the other observations, this is not the final visit. This is the final visit observation. So I will take y in future. I'm going to filter the data by using this y so that I can understand, okay, I should use this observation for analysis purpose. Now overall, these are the variables that we have. Now clear everybody? Is this clear? Now, by the way, most of the SGM programmers, clinical SAS programmers, think Adam is a very, very difficult. The reason why Adam is difficult, if you do not have a strong SGM IC guidance, if you do not have a strong SGM knowledge, then you'll feel that you'll think like Adams are going to be very difficult. But if you are good enough, if you are strong with your SGM skills, if you have SGM knowledge, then Adams is going to be very, very easy. Okay? And one more important thing. So how we are creating Adam data from where we are creating Adam data set? We always create Adam data set from where?
SGM.
You will not find any new data here. Whatever the data that you are going to see in Adams, all the data you are familiar with already that we have created SGM database. Nothing new. From SGM data set, we are going to create Adam data set. So all the data you already know that. And in SGM data set domain, in SGM, how many domains we have seen? According to guidelines, we have 40 domains, isn't it? And out of 40, how many domains we have worked on? We have worked on around 15 or 16, I think around 20 we discussed. In Adams, how many domains we need to discuss? We have to discuss only 3. And one more important thing, when it comes to interview point of view, I'm going to discuss all the questions. We are going to get only those questions in the interview. You will not get one extra question. And those questions is going to around 20 to 25 questions. Or maybe 30 to 40 questions. If you were able to answer those 40 questions, you are going to clear your Adams. That's for sure. Not more than that. So, in the next 2 days, I'm going to discuss about Adam IC guidelines. By the time, please brush up your SGM skills one more time, SGM knowledge, so that Adams is going to be very smooth and easy to understand. But if you are not sure about your SGM data sets and SGM knowledge, and Adams are going to be very difficult, and you at the end of Adams will feel, I do not want to keep Adams in my resume. I'm happy with SGM, I'll go to only SGM. But when you compare with SGM, whatever the effort that you put in SGM, if you put only half of that into Adams, that would be fine enough. Understand this one? Now, why we created Adam data set? And sometimes why we have created? Because we couldn't able to use SGM data set directly
For analysis purpose.
So I require an intermediate data set, and that intermediate data set is called Adam. I told you Adam data set is an analysis study. It is one block away from where? From analysis report. Okay. So now, an Adam is just intermediate. Where we have all the clinical trial data now, where we have all the clinical trial data, we have all the clinical trial data. Okay. If somebody asks you, now I'm asking you a question. Take this as an example. Okay. Now if I take it, what is that? Now you propose it, you have created vital signs SGM data set, just imagine. And then we have created Adam data set, we call it an EDBS, analysis data set of vital signs. And finally, your report is showing that, by the end of the study, there was a reduction 27, the value is 27 reduction in systolic blood pressure from the baseline to end of the treatment. Now this is the proposal that we have given. Final conclusion is 27. Now I ask you, how we got this 27? Can you show me the proof? From where you got this 27? Tell me how we got this 27. And as soon as I ask the question, you're going to tell me, I did the analysis, the statistical analysis. Tell me, what is the statistical analysis that you have? How you have done the analysis? From where you have done this one? And you can say that I use some kind of statistical measures, procedure, I use the statistical procedure, I have done that one. Now tell me, through the statistical procedure, which data set that we have taken? Which data set that we have taken to this statistical analysis? What is the source data set?
SGM.
No, Adams variance, right? From this I use it, for analysis part. This is the source data set. Now, in the source data set, tell me from which variable we have taken the values to do this analysis. Remember, we have created 2 tables, eval, and what other variable we have replaced. Now I'm asking the question, how we got this value into eval? Eval demo 121 only, based on 148 which you need. You 121, 1 from where you got that one? Now, you have to put the relationship with, I got this eval value, from where you have got this one?
This one.
From STRSN value. From where you got this value? Again, this is also STRSN value, but when PLFL is equal to y. You're going to show me that. Now, STRSN recognition is very different. From where you got this STRSN? We got this STRSN from vital sign STRM, STRSN, PS STRSN. But bro, the STRM data set over the data condition is different.
Very good.
Very good. From the data. The data condition is different. How we got into this data? See, here you have created data set from database. We extracted the data from the database. But the database of the data condition is different. How we got this data in the database?
CRF.
From CRF. How we got this information in the CRF sheet? Now, you are going to show me the instrument that you have collected, that you have used to collect this information. The instrument, the device, the test that you have conducted. Okay. You should not lose any connection between this 27 to the instrument. You cannot have any connection break in that one. You know what this connection is called? You should be able to trace it back from the analysis report into the process that you use. And to use the process, what is the source data set that you use? To create the source analysis, what is the source SGM data set that you use? To create the source SGM data set from where we have created data. How we got this data from the database? How we got this the CRF sheet. How we got the information in the CRF sheet? By using a device, an instrument, a diagnostic method, and whatever the method or instrument or device that you use, you should show that one. You should not lose anywhere the connection, and this is called traceability. You should not lose the traceability anywhere. If you miss the traceability, if you lose the connection in between these two, now you cannot support the result. You cannot defend your input. If 27 allows you to చెప్పాలి అనుకోండి, ఈ కనెక్షన్ చూపించాలి అనుకోండి, if you didn't able to show the whole connection to the source instrument, you fail. Nobody will believe you. Nobody will believe in the report. So if nobody will believe in the report, so that means you have did some manipulation. So the now FDA will not give any permission. So the whole concept of the Adams is a traceability. Since it's an intermediate data set, it should be a bridge like a bridge between SDM data set and an analysis report. So I told you what the main concept of SDM. The whole SDM revolves around the observations collected from subjects. Now what is the main concept of Adams? The main concept of the Adams is the traceability. If somebody asks you, tell me in one sentence, one word, what is the importance of Adams? Adams is nothing but only for the traceability. What is the traceability will do? Traceability brings the transparency. So that means traceability undanukondi, you can show 100% the correction between your finance report into the device that you use it to get that information. So you can 100% defend the result by showing that the linkage. So that the traceability brings the transparency. If you have a transparency, then you can defend your results. You can get the confidence in your finance report. If somebody asks you, by showing this traceability, you can easily defend yourself. You know, I'll give you an example. Why nowadays everybody is encouraging online transactions? Why everybody is encouraging online transactions? If you do only online transaction, there is going to be traceability. How much salary you got, you know, so today how much you spend, yesterday how much you spend. If you do anything, everything is online transaction. You're going to have a proof. From where you got the money, how you spent to, whom you have to transfer the money, how much that you have transferred, and what date you have transferred, for what purpose you have transferred. Everything is going to be recorded. So everything is recorded, there is going to have a proof. And that proof will give you the traceability. From where the fundings are coming and how your expenditure is. And if you have that fund, then you can show it to everybody. So the traceability comes. If the traceability comes, you can defend yourself. Everything I'm getting, why did my salary? I think it's a black money. I'm doing like this one. So this everything is not transparent. Isn't it? So the traceability brings the transparency, and the transparency is very important to get the confidence of a final report. You can easily defend your hypothesis. So the whole Adams revolves around the traceability and the transparency. So the main focus of SDM is observations collected from the subject. Do you know what the main focus of the clinical trial? Anybody? The main focus of the clinical trial
Safety of the subject.
very good. Subject safety. The subject safety is very, very important for clinical trial. The whole clinical trial revolves around the human subject. The SDM revolves around observations collected from the subject. And the whole Adams revolves around the traceability and the transparency. Clear, everybody? If you understand today's class, now Adams is going to be, this is the overall Adams concept. Do not worry about this param variable, eval variable, change, baseline, base variable. I will explain all those variables later. But first, you get yourself into Adams, so then it is going to be easy to understand. Okay? Is this clear, everybody? I'm strongly recommend you how to keep Adams and tables and listings in your resume. If you keep that one, so you're going to be eligible for now end to end of the clinical study. Clear? From tomorrow onwards, please join at 7 o'clock. We'll start the class by sharp 7 o'clock. Okay? Okay, guys. Okay, and do not worry about the guidelines and the notes and what and all you have to do. I'm going to upload the guidelines again. For Adams, if Adam is also, we are going to have the guidelines, but it is not going to be that much use. For SDM, remember how many pages that we have 3.2? Anybody? 398 pages or something. But Adams, it is not going to be those pages, it is going to be 110. But we have to take 4 documents. One document is 110, other document is 70 pages, one more document 40 pages, like that. I will tell you where we need to read, which document you should read, and I will tell you all the things. Okay? Some people, they will take Adams, so maybe half a day, 1 day class, max of 2 days, but we discuss Adams very in depth, and we are going to discuss around 10 to 15 days. So, again, Adams, you can take 2 years, only on Adams. So, already we have seen SDM, 2 years, 2.5 years, Adams 2 years, so you can keep over 4.5. Okay? Clear, everybody? Okay, then see you in tomorrow's class. We'll discuss about Adam and the guidance in tomorrow's class.
Thank you. Thank you, sir.
Thank you.